In this video, we're being asked to show that sine squared alpha minus sine squared beta is equal to sine of alpha plus beta times sine of alpha minus beta. And before diving into this, it's probably worth noting just how similar this result that we're trying to prove is to the difference of two squares rule that you're probably already familiar with. Effectively, this is almost the sine function version of the difference of two squares. And to help make that really clear, what I might do is, hopefully you're familiar with the idea of this notation, sine squared alpha. That's basically just sine alpha squared. We take the sine of alpha and we square it. And it's the same for sine of beta. Sine squared beta is sine of beta squared. So we're being asked to show that that's sine alpha plus beta times sine of alpha minus beta. And it's worth noting that the rule for the difference of two squares that you would have learned earlier in your math journey, so the difference of two squares, we can write, you'll often see it is a squared minus b squared. So if we take two values, a and b, and we square each of them and take the difference, that is the same as a plus b, a minus b. And notice that that format, that structure of that result is very similar to what we've got here. Instead of a and b, we've got sine alpha and sine beta, and then it's the sine of alpha plus beta, sine of alpha minus beta. We're effectively just putting the sine function in front of each of these components. So the way we'll try and prove this result, we'll start from the left-hand side and we'll do our manipulations to get from this left-hand side to this result on the right-hand side. And we can begin by actually using our difference of two squares result, and wherever we see a and b, we can just put sine alpha and sine beta, since we're dealing with sine alpha all squared and sine beta all squared, which is the equivalent of a and b here. So we can start by saying that our left-hand side, sine alpha all squared minus sine beta all squared, is sine alpha plus sine beta multiplied by sine alpha minus sine beta. And from here, we can make use of some work I've done in some prior videos, which actually worked through some results in relation to sine alpha plus sine beta and sine alpha minus sine beta. So what I'll do is I'll put some links up to those videos so that you can go watch them if you haven't already. But for the purpose of this video, I'm just going to insert those results and see what we get. So the prior videos, what we worked out was that sine alpha plus sine beta we can write as 2 times sine of alpha plus beta on 2 times the cosine of alpha minus beta on 2. And so that deals with our sine alpha plus sine beta, and that's now being multiplied by sine alpha minus sine beta, which in the prior videos we showed is the same as 2 times the cosine of alpha plus beta on 2 times the sine of alpha minus beta on 2. So those two results come from the prior videos. Again, if you haven't watched them, it might be worth taking a look just to see how we get there. Now, what I might do is just bring the alpha plus beta on 2 items, so the sine alpha plus beta on 2 and the cos alpha plus beta on 2 together, and then the alpha minus beta on 2 items together, which we can do because everything's being multiplied, so the order doesn't really matter. And then it will become really clear what we can do here. So let's just write that out. So we'll say that's equal to 2 times the sine of alpha plus beta on 2 times the cosine of alpha plus beta on 2. So that deals with these parts here. And then we'll multiply that by what's remaining. So we'll have our 2 times the sine of alpha minus beta on 2 times the cosine of alpha minus beta on 2. And that deals with this part, this 2, and this sine alpha minus beta on 2. So we've still got the exact same thing. I've just rewritten the order slightly. so that we can really see what's going on with essentially what can be simplified with our double angle formula, because we've got 2 times the sine of something times the cosine of something, and we've got that twice. And hopefully you're familiar with the double angle formula for the sine function, which says, the way you'd normally see it would be that the sine of 2 times an angle, let's call it theta, is equal to 2 times the sine of theta cosine of theta. So in our case, we've got the 2 times sine of something cosine of something. So we know that we can then write that as simply the sine of 2 times that angle. So we can continue on with our proof, saying that 2 times the sine of alpha plus beta on 2 cosine alpha plus beta on 2 is equal to the sine of 2 times this alpha plus beta on 2. And the 2 sine alpha minus beta on 2 cosine alpha minus beta on 2 is the same as sine times 2 times alpha minus beta on 2. Now, these 2's can cancel, so that we then simply get left with the sine of alpha plus beta times the sine of alpha minus beta. And that is exactly what we were being asked to show, so that's as required.
Sonic boom!
So there you have the proof. We've effectively proven a sine function version of the difference of 2 squares, making use of the difference of 2 square result, as well as some other results that I've shown in some prior videos. So this work in the prior videos, the reason I did that was to step by step take you through what allows us to ultimately prove this very interesting result. So hopefully you've been able to follow along with all of that, and tick boom.